Okay, this video is our second video using numbers in science. And so we're going to talk about numbers in measurements and calculations and your significant figures. All right, so your least precise measurement is what's going to limit your certainty of your calculated value. And so your least precise measurement is going to be what determines how many sig figs you have in your final answer. So there are two rules for calculations with significant figures, and one is for multiplying and dividing. And so what you do when you multiply and divide, it's really quite easy. You count the number of sig figs and all of the numbers that you're multiplying and dividing. And then your final answer can have no more sig figs than the number with the least amount of sig figs. And so we're going to practice this. Let's pretend like we're getting the area of something. And so somebody has a really precise ruler, and it measures 6.221 centimeters. How many sig figs is 6.221? 4. And then somebody else with another ruler can only measure to two significant figures, and they get 5.2 centimeters. Well, when you punch this into your calculator doesn't pay any attention to significant figures at all. They just spit out all kinds of numbers, and all those numbers at the end are really meaningless. So when my calculator gave me 32.3492, centimeters times centimeters is centimeters squared, so that would be my unit. But I should not report all these numbers in my answer. Remember, I had 4 significant figures in the 6.221, and I only had 2 significant figures in the 5.2. So I should only have 2 significant figures in my answer. And so I should report my answer as 32. To report to 2 significant figures, I should say that it's 32 centimeters squared. All these other numbers, they are not significant, and it's wrong if you write them down because you're writing down numbers that you don't really know what they are. All right, so here we go again. Here's a division problem. Density is mass over volume. And so what we have here is we have a mass of 14.579 grams. So that would be 5 significant digits. Here the volume is 20.2. That 0 is in the middle. We're going to count it. That's 3 sig figs. 3 is smaller than 5. We should go ahead, perform this on our calculator. We get this big long number. We need to report it to 3 sig figs, and so it would be 0.722 grams per milliliter. We had grams in the numerator, milliliters in the denominator, and that's my answer to 3 significant digits. Addition and subtraction rule is a little bit different. You have to look at decimal places. The result has the same number of decimal places as the measurement with the fewest decimal places, and you will round to the last decimal place of the least precise number. So here we go. We've got this beaker, and it's empty, and it has a mass of 112.9 grams. And then we put some water in it, we put some salt in it, and we put some sugar in it. And so it looks like we used a different balance for all of these amounts. When we add all this together, we get 187.9492 grams, but the correct number of sig figs, well, this only has 1 decimal place, so we can only report it to 1 decimal place. So it's 187.9, and that's grams. All right, so see, this is a little bit different. Remember, we didn't count how many significant figures we had. We looked at how many decimal places there were, and then that's the least number of decimal places is what we reported to. All right, so multiplication and division, you count the significant figures. Addition and subtraction, you count the decimal places. And again, we're going to really practice this in class. Bye.